Is this glass empty or full? Well, here on Earth, even an empty glass is 100% full because it's full of air which is packed with different molecules. In fact, 1 cubic centimeter of air contains almost 30 quintillion molecules. But can there ever be a truly empty glass with absolutely nothing inside of it? Well, if you remove air from inside the glass, you get what's known as vacuum or empty space, but you can't remove all particles. The best vacuum scientists have created is an ultra vacuum, which contains 100 particles per cubic centimeter. If you leave air though, you find space vacuum, which is the area that separates different celestial objects. Intergalactic space only contains 1 particle per cubic meter, and that's very close to nothing. But can there ever be absolutely nothing at all? Well, to answer that question, you have to look at quantum mechanics. Quantum mechanics says it's impossible to find absolutely nothing because there are gravitational and electromagnetic and other fields which extend forever according to the quantum field theory. When something excites the field, a little kink is created, which is a particle. Think of it as a bowl of water. When I put my hand in it, I'm exciting the field, and the resulting drops of water are the particles. Each one of the 12 fundamental particles of matter is created this way, which are the smallest objects we know, and they make up atoms, thus everything around us. But when there is nothing exciting the field, it is not still. There is something known as the zero-point energy. It is not exactly zero, but the lowest energy a quantum system may have. This energy is known as the vacuum energy, and it can be thought of as quantum fluctuations. That means that the field is like if the water was boiling all the time. Those fluctuations are what's known as virtual particles, and they constantly pop to existence and then immediately annihilate each other because one is a normal particle while the other is an antiparticle. They are made in the same way as normal particles, but they are temporary. They're like 2 drops of water hitting each other and then falling back into the bowl. But there's a quantum fuzziness in the amount of energy in each place because according to the uncertainty principle, any object which exists for a temporary amount of time cannot have a precisely defined energy. So vacuum energy exists everywhere, so there has to be some effects that we can see. One of those effects is the Casimir effect. It says that if 2 pieces of metal are put nanometers away from each other, they're gonna be pushed together. One of the best explanations of this is that the virtual particles are getting reflected off the face of the metal, and there's more virtual particles pushing on the outside than on the inside. Another effect is related to the expansion of the universe. We know the expansion is accelerating, but we don't know what's causing this, thus we call it dark energy. There are theories that dark energy and vacuum energy are related to each other. How? Well, the energy of the annihilation of the virtual particles could be dark energy. Another theory is that as the universe expands, more empty space is being created to fill the gaps, and this increases because the gaps are getting larger, making dark energy just a property of empty space. But those are just theories, and we still have plenty of questions to answer.